What would I say to somebody who wants to do earth sciences? Well, firstly, I'd say do it.
Hi everyone, and welcome to the Oxford University Open Day. My name is James Bryson, and I'm the Tutorial Fellow for Earth Sciences at University College.
My name is Erin Saup, and I'm a tutor in Earth Sciences for St. Hugh's College.
Hi, I'm Roger Benson. I'm tutor in Earth Sciences at St Edmund Hall.
Hi, I'm Stuart Robinson. I'm one of the tutorial fellows in Earth Sciences at St Anne's College and an associate professor in the Department of Earth Sciences.
Hi, I'm Richard Katz, a professor of Earth Sciences at the University of Oxford.
Hi there, my name's Conor McNichol. I'm a professor in the department and I'm also one of the admitting tutors at Exeter College, and I'm currently the head of teaching in the department, so I oversee aspects of the entire curriculum.
Hello, my name is Hauke Marquardt. I'm an associate professor for solid earth geosciences here in the Earth Science Department at Oxford, and I'm also tutorial fellow at Worcester College.
Hi, my name is Brooke, and I'm a tutor in the Department of Earth Sciences and at St Peter's College in St Edmund's Hall.
What's up, folks? My name's John Wade. I am an associate professor in planetary materials at the Department of Earth Sciences. I'm also the faculty outreach lead for the department.
I'm a paleontologist, so I study fossils and the history of life on Earth. And that's what I teach on our Earth Sciences course.
My particular specialty is paleobiology. I'm interested in understanding the evolution of life on Earth.
My research mostly focuses on the evolution of the early solar system. So I look at meteorites to understand how planets form and how the solar system formed, and how we went from this chaotic disk of dust and gas in the early solar system to an organised collection of orbiting planetary bodies. And I'm working with NASA at the moment to try and understand the evolution of different types of asteroids.
My research is focused on trying to understand how Earth's climate has changed over geological time and what the implications of past climate change are for understanding the future. I use the chemistry of rocks and fossils to reconstruct aspects of past climates and environments, and use these to build a picture up of how the Earth worked in the past.
My research interests are in understanding the early evolution of life on Earth and the co-evolution of life in Earth's surface environments. I want to understand how you go from an early inhospitable Earth inhabited only by bacteria to the modern Earth we see today with its bewildering array of biodiversity and large animals and organisms.
My research focuses on using high pressure, high temperature experiments to simulate the conditions of Earth's interior and other planetary interiors, and then basically measuring physical properties of materials while they are in these, under these deep planetary interior conditions. So the ultimate goal is to use these physical parameters to constrain how planetary interiors works, how Earth's interior works, and how it has evolved over long time scales.
My research, think about this. So what sort of research do I do? Well, I might study planetary materials, and primarily I'm interested in things like how the planet formed and the effects we see on that around us today. So to give an example of the sorts of things we're interested in, it's, how does the Earth's core form, and what are the implications for the Earth that we see around us today?
My research centres around understanding the evolution, origin and dynamics of the Earth's magnetic field. And in particular, I'm interested in how that field has behaved in the past. All rocks have a tiny fraction of magnetic minerals within them. And so we can analyse, or we can look at the record of the magnetism that's recorded in rocks, and that tells us a lot about past magnetic fields.
Being an earth scientist is a bit like being a detective trying to piece together a puzzle to understand Earth processes. I'm fascinated by Earth's biodiversity both today and in the past, and I like to share that enthusiasm with my students.
Earth Sciences uses other science subjects, physics, chemistry, to some extent biology, certainly maths, to understand the whole Earth system, how it works and its deep history through time. So the ocean, the atmosphere, the solid Earth and geology, and the biosphere and the evolutionary history of life on this planet.
My background is in geology and geophysics, so much of the teaching that I do in the department sits at the interface between those two subdisciplines. I'm also heavily committed to the department's undergraduate field programme, and so I will appear on all of the first year field courses that you'll go on and some of the later ones.
The earth sciences are the tools that we use to understand the story of the earth, which is inherently the story of the human race as well. It's how to understand the functioning of an entire planet and everything on that planet, from the way that the core and the mantle work, all the way through to the oceans, the atmosphere and the biosphere. All of these different components interact in different ways, and earth sciences is the study of this whole mechanism that is our planet and its deep history as well.
My teaching focuses on fundamentals of how sediment is produced, transported and deposited at the Earth's surface, and how the sedimentary record can be used to reconstruct the Earth's history of environmental and climatic change.
I do teach the physical thermodynamics part of the course in the first year and the seminar on mental structure and dynamics for fourth year students.
Primarily I teach either on the machines, the instruments, I teach the analytical techniques, and we will teach those both to postgraduate students, staff. On a lecture basis, I teach fourth year planetary chemistry, and that's a sort of a seminar-based course. So the idea is that we go from start to finish. In that course, we look at how the elements are formed in stars, how the elements condensed into the planetary materials, things like the meteorites, the chondrites, how planetary differentiation went on, how the Earth formed, how Mars formed, and how the gases and the atmospheres evolved and developed, and ultimately how life develops on the Earth.
Tutorials are a special form of teaching that we have in Oxford, where a small group of students, so maybe 2 or 3 of you, spend time, maybe an hour once each week, with a member of faculty, so a professor, or possibly a researcher or a postgraduate student, really getting to grips with part of the course. They're intended to be challenging, they're intended to be thought-provoking, and they're really intended to help you think beyond the basic knowledge of the fundamentals into sort of what are the implications of this for our understanding of science.
My tutorials with students are diverse. They can range from discussing the scientific literature on which students have written essays, to debates on the reality of species, to understanding the distribution of deep sea sediments. My tutorials can also have a practical element. So for example, we often examine rock and fossil specimens, and we discuss their characteristics and any inferences we can draw from those rocks and those fossils. For example, their paleo-environmental context.
And these are these small group teaching sessions that are fairly unique to Oxford, and they involve you doing some work beforehand, handing that work in, and then sitting down with one of the academic members of the department for about an hour as you go through the answers to those questions. It's a really great system because it introduces you to world experts and you can ask your questions and sort of work through the problems together. And it's an amazing system where you can really get to grips with the topics you're learning in these small groups in this very personal manner.
I spend quite a lot of my time giving tutorials and teaching in the field. These are really great aspects of our course that allow really close working with students and a really in-depth discussion of topics of interest.
Tutorials are a really good way to get to grips with the course material in a way that you can't do on your own or with a large class and practical session. So a group of us would sit down and then go through, say, a sample on a microscope in really fine scale detail, and I can talk you through all of the different features I wouldn't have time to do if we were discussing it in, say, a lecture or in a practical session.
A tutorial in Oxford is all about discussing about some topic of interest, either related to the course or going beyond the actual coursework. And it gives you as a student the opportunity to really ask all the questions that you have and probably don't dare to ask in the framework of a big lecture. And it gives me as a tutorial fellow the chance actually to profit from your new ideas and just have nice and interesting discussions with the students.
The Earth Sciences has centralized their admissions process. So if you apply to St. Hugh's College, I may not interview you. But if you do receive an offer of an admission, we try to honor your college choice.
The colleges are all slightly different. And if you have the opportunity to spend time visiting colleges or learn more about them online, then you should do that. And you should try to make a decision about which college might be best for you.
One question I often get asked at open days is about how do I choose a college? Most colleges all provide the same sort of things. They'll provide. So really, you've got to make a decision based upon what you're looking for, what you're interested in. Do you want to live somewhere close to the city centre that might be very busy and the hustle and bustle of what's going on in the town centre? Or do you want to live a bit further out where it's a bit quieter? Do you want to live in something akin to a Hogwarts castle? Or do you want to live in slightly more modern accommodation? Is there a particular sport you enjoy? Is there a particular society you're kind of looking to join? Those sorts of things might be more stronger in some colleges than others, and you may feel drawn to them. Whatever those reasons are for choosing a college, they're all good reasons. But the most important thing I want you to know is that whichever college you choose, your application to Oxford to read Earth Sciences won't be determined by that choice of college. We will consider your application irrespective of which college you choose. So we run a system where we consider all the applications across the university, blind of the college choices, and come up with our final list of who we want to offer places to at Oxford to read Earth Sciences. Only then do we try and fit applicants' choices of college to college places. This does mean that some people may not get a place at the college that they originally applied to, but this is fine. Everyone seems to discover that they enjoy their eventual college. Everyone finds that they gain college loyalty pretty rapidly once they're actually in Oxford.
In terms of getting onto the course, your choice of college doesn't really matter because we have this centralised system. So all of the applications are assessed independently of which college you've chosen. For an earth science student, colleges act more as a social base. So have a think about what kind of social activities you like to do, what kind of sports, what kind of clubs you might want to join, and then have a look at the colleges that offer earth sciences and see which one of those best fits your style.
So during admissions interview, we want you to feel as comfortable as possible, and we want you to do really well in a way that reflects your enjoyment of science, your love of the subject, and your motivations. We're going to ask you science questions, and we're going to draw to some extent on the knowledge that you've gained through studying science at A level. And what we really want to understand is how you think. We want to understand what motivates you, and the extent to which you're really getting to grips with questions in science.
We're mostly looking for how you think. So we don't necessarily expect you to know the answer to a question, but we want to know how you think and how you can get to an answer and how you can work from the information we've given you towards figuring it out. We don't just want you to know things, we want to know the way that your brain works.
You might have heard that Oxford interviews have quite a reputation for asking strange questions to try and trip you up, but that's generally hearsay by people who've never been here. When I interview an applicant, I'm wanting to find out about that person. I want to find out how you work, how you think, how you solve problems. And what we're really looking for in that interview is some kind of enthusiasm and passion for the subject. The kinds of questions we ask you will be fairly straightforward things, such as going into detail about what you've written on your personal statement, maybe some basic science questions. We try to make interviews pleasant, fun experiences because we want to get to know you. We're interested in seeing you perform at your best.
The best preparation for interview is to be engaged with the subjects that you're studying at school. You may be studying physics, you may be studying chemistry, you must be studying maths.
So the main piece of advice I would give is always keep talking. If you go into an interview and someone asks you a question and you can't really answer it, if you just sit in silence, they might not know that you've got an amazing brain. So just talk through what you're thinking, express yourself clearly in the interview, and that will just help the discussion start where you can have some help from the interviewer to hopefully reach the answer.
But I think the enthusiasm, have a think about, the motivations for doing the subject. And there are lots of motivations. I mean, mine would be very different to yours, and they'd be very different to somebody else's.
My top interview tips would be just to be yourself. Take time to think about your answers. You don't have to jump straight in. If you can't think of an answer off the top of your head, then tell us. If you don't know, that's perfectly fine. Tell us and we can have a chat about it. Just relax and enjoy having a chat about some cool science.
Today I want to talk to you about writing a personal statement to accompany your application to Earth Sciences in Oxford. The Department of Earth Sciences is looking for applicants who can demonstrate some understanding of the course that they're applying to study, and who can also demonstrate a deep motivation for studying that material. Your motivation needn't come from having climbed some tall and dangerous volcano. It could be as simple as having had a rock collection when you were a child that you were fascinated with. Or maybe it's your concern about climate change and your interest in understanding how it works and what its effects are. It's not really important what it is, but rather why it motivates you and how it excites you to study Earth Sciences. By explaining your motivation, you can convince us that you'll make the most of the opportunity to study Earth Sciences at the University of Oxford. I hope this video has been helpful. Now get started writing that essay.
When college tutors are reading your personal statement, what they really want to know is that you know what you're signing up to when you want to study Earth Sciences. We want to know what motivates you. We want to know that you're really invested in the study of science. We want to know that you're doing your best and that you're a sort of switched on, smart person who really wants to use everything we know about science to understand the Earth that we live on and how it works.
There's a lot of misconceptions about what kind of person should go to Oxford, and some people might not apply to Oxford because they think they're not an Oxford type. In terms of Earth Sciences, those misconceptions are completely unfounded. In your personal statement, what we want to see is a person who's interested in and passionate about studying Earth Sciences, someone who's curious, who needs to know how the world works, and who has the drive and ambition to take on a challenging course such as ours and then excel at it. And that has nothing to do with your background, where you've come from. We have people from all over the world and from all kinds of backgrounds in this department. And that's what makes Earth Sciences such an interesting topic, and this department such an interesting place to be, is that we have that level of diversity in the topics you'll study and in the people that you'll work with. Also, write your personal statement yourself, and it doesn't have to be too polished. We're not judging you on your grammar in English and how many big words you know. What we want to see come out in your personal statement is your personality, is a statement of who you are as a person and why you would be a good person to come on this course.
Just show, I mean, for me, I think, if you read a personal statement or something like that, it's enthusiasm for the subject sometimes doesn't come across. So be enthusiastic about the subject. And the obvious one, and I know teachers will tell you this all the time, is, put things on your personal statement you've actually done. So don't say you do an extended project in meteorites and then you turn up for an interview and somebody says, oh yeah, about that project you've done on meteorites, and you go, I haven't done it yet. Also look at the course prospectus. So every Earth Science course is different. Some will have different focuses. Some will have more paleontology than other courses. Some will be more maths based. Some will be more observational based. But definitely find out more. I mean, you don't want to turn up to a course that you haven't checked out first. That'd be awful. So thank you very much for listening. I hope I haven't bored you, and hope to see you soon. Cheers.